Okay, so we're going to talk here about this lab you're going to be doing today and how you kind of want to get it set up and kind of working from there. Okay, so your objective today, remember, is to show that all energy is conserved. So we do not create or destroy energy. It simply changes forms or something like that. Okay. So if you remember, our equation for kinetic energy is 1/2 mv squared. That means v to the second power, so v squared. And potential energy, remember U means potential energy, is mass times gravity times height. All right. Now, what I've thrown another equation in here, and it's this equation over here with D equals V times T. Now, this is just a relationship. What this really is just this equation rearranged. So it's actually just V equals D over T, so that's distance divided by time equals velocity. We've just rearranged that to solve it for distance, so it's velocity times time, and that gives us our distance. Okay. Now, what's important to remember here is and I'll come back to this, is that our time is always going to be the same. It's never going to change. So the only thing that's going to impact our distance that we get is our velocity. So we're going to kind of use our distance to approximate our velocity because it should be a standard ratio. All right, so here's what you're going to do. You're going to take the Hot Wheels tracks, and if this is your table, okay, so I made a little makeshift table here. And what you're going to do is you're just going to put the two tracks together, and then you're going to kind of make a little curve like this. And you know what? That's not very good. Let me try that again. All right, so you're going to make a little curve that does this, okay? Um, all right, now what you're going to do is on the top here that is where you are going to release your little steelier marble. Okay, so you're going to release it from right there, and it's going to roll down, and it's going to go flying off the edge. Okay, and what you're supposed to do is compare the potential energy it has here to the kinetic energy it has here, because we don't have an easy way to measure its velocity. Like I said, what we're going to do is we are going to use this distance over here. We're going to measure how far it comes out flying here as a measure of that velocity. And because if you remember from the video we showed on Friday, that it doesn't matter how fast this comes rolling off over here, it's going to hit the ground at the same time. So if I drop one straight down, it'll hit the ground at the same time as if we roll one off really fast. Remember, even in the Mythbusters, they shot a bullet straight sideways and dropped one straight down, and they got them to hit at the same time. All right. So again, our time here isn't going to change. Our velocity will. So the distance is how we're going to indirectly measure that velocity. Okay. All right. So what you're going to want to do here is you're going to want to run 4 trials at each height. Now, what are you going to be measuring when I say height and things like that and distance? Well, what I'm talking about is this. So this right there, that height right there, that is the height. So you're going to want to run this through 4 times at each height. Now, every time you do this, what's going to happen is and let's pick a different color. Let's go purple. All right. The ball is going to come flying off of here, and it's going to go some distance and land out here. All right. Now, it probably won't land in the exact same spot every time, but it should land pretty darn close to the same spot every single time. All right. And so what you're going to do is you're going to measure how far it was from here to where it landed. Okay. And that will be our distance. So that is our data that you're going to put on your data table. and you're going to run that 4 times for this height. Now, you're the scientist here. So if you get one that gets really weird, so like you get one and all of a sudden something happens and it goes like right there, but the other 3 landed out here. Well, clearly something happened there. Maybe it bounced, maybe it ran against the side, maybe like it, something happened. You're allowed to, okay, that one wasn't a good one. We don't like that one. Let's get rid of that one. Let's ignore that and run another trial. Okay. Now, what you should be able to do is you need to measure the distance that the ball travels. Now, you're going to have to be very careful with that measurement, okay? Because where do you measure from? And the answer is you got to be careful. You got to measure from the launch point, all right? So if we draw a line straight down from where it's launched, okay, where this line hits the floor is where we want to start our measure, and then we want to measure this distance right here. So that is the distance we want to measure right there. Okay, so you're going to run 4 trials at this height, get those 4 distances, average them, and go from there. Now, the trick might be, okay, so how do we find where to measure this spot on the floor? Because you'll notice it's not the table. It's not the edge of the table. You want to measure the launch point. And actually, if you're doing this well, your track should stick out off the table a little bit. This is where the plumb bob comes in. All right. And so if you remember, I showed you that plumb bob on Friday. And so the plumb bob is really heavy and it kind of looks like this. Okay. And if you hang that thing down like so, okay, I'm just trying to color it in a little bit there. If you hang it down, it will make this line straight down, and you'll be able to mark on the floor with a pencil, not a pen, mark on the floor with a pencil where the launch point is so that you can get this distance, okay? Now, once you have that and you've taken it, what you'll need to do is you'll need to get some carbon paper, all right? You'll need to get the carbon paper. You'll need to lay the carbon paper down right here, okay, on top of your white paper, all right? And when the ball hits the carbon paper, it will leave a mark on the white paper underneath. You then should be able to measure and get that distance. Now, you're going to have to share carbon paper. I don't have enough for every group, okay? Also, you need to be extremely careful with my carbon paper because it's all I have. So you need to be careful with it. Do not rip it. Do not mess around with it. Okay. All right. So in order to do this successfully, you're going to need to take at least 3 different heights. Okay. And that is if you are very, very smart about what your heights are and how they go, and you really think this through and look at these relationships. Okay. I'm guessing it'll probably take you 4 or 5 different heights to do this. All right. Now you need to think like a scientist. How are we controlling this? Are we making sure that we're getting good data and things like that? One last thing that I should mention before I let you go here is this last bit of the track needs to be taped down. Okay. It needs to be perfectly flat. So like it's the last half of the track is what we have. The reason we tape that down is so that it's flat. If this thing is at an angle, either down or up, it will change the way the ball is launched and it won't go the right distance. So make sure that this is flat, at least the last foot before it goes off the edge of the table. Those are some of the things to look out for. All right. Like I said, this is a lab where you're supposed to figure it out. It's going to be challenging. It's going to challenge your math. It's going to challenge your inquiry skills, but you need to get a bunch of data points today and go from there. All right. When you are finished, take a look at the second video that I've prepared and see if you can't start analyzing.